Hello everyone, this class for math elective, okay? Now we still continue for the limits of functions. Okay, today this section for the next one is talk about the the lesson is continuity. Continuity or continuous, okay? So first of all, I would like to talk about the definition first, but this is informal, okay? So what the meanings of continuity or continuity informally? So you see from the graph, actually it's a form similar to the previous one, but now we consider it's a continuous, the function is continuous or discontinuous. How we consider by, you see from the graph, the first one here, for example, this is graph number one, number A here. If you lead from the line, this is a function f of x, right? If you lead from left, lead up to here, right? When you make this point, this is a C, that means x equal to C here. Can you continue drawing or lead? We can do, right? Because when you upload to this one, when you want to draw up to the right hand side graph here, you can continue moving, right? Because it's a back dot. So when you make this from the left up to x equal to c, the function of this one, you don't need to lift up your pen or pencil, right? You can continue smoothly drawing. So in this case, we call continuous. This one we say is the function f of x, the function f of x. Okay, when x equal to c is the axis. For example, what the answer? For example, you lead from here. At this point, you really come here. Assume this one's a D point, okay? Assume this is a D. So then you equal to D. Then this one, this function is a continuous function. Okay, don't forget you still need the value of D when you lead. But at the same time, if I ask you the limit, okay, from this one, limit f of x, when x approach to C, right? So what equal to C equal to D, okay? This is a D, okay? C equal to D, because when you leave from the left and from the right, when you make this point, you get D. So that means function f of x, right? Function f of x here and limit f of x, they are equal. So then this one is so then we can say this function is continuous, okay? Continuous functions, okay? Then you can see the next one. If at this one again, to when you lead this graph, right? This function from the right hand here. If you lead up to upload to this point, and from the right you lead at this point, this one back dot, you see? So then you see you need to lift your pen or pencil or not. When you lead up to left hand side to the right hand side, you still can continue because it's a back dot. So in this case, it's also continuous, okay? But if I ask you this one, if f of x, okay, when x equal to 0, then this one is continuous or discontinuous. You see the graph. If you lead from the left here, the bottom, so the graph gonna be at the bottom here, right? You keep leading, keep going here. When equal to 0 here, right? This one look like this one should be asymptote line, correct? It's a vertical asymptote. So this one keep going to approach closer, right? Approach closer to then what? Y equal to infinity, and on the right hand side here become plus infinity. In this case, it discontinuous. Because why? Because you see the limit from the left and from the right. This one equal to negative infinity and this one plus infinity. So if I ask you this one, f of x when equal to 0, this one is what? You can say this is a no solution, okay, or no answer, right? But when at the same time, if I ask you limit, this one, limit f of x, when x approach to 0, what the answer? You will say, if you leave from the left hand, right? That means if you leave from the limit f of x, when x approach to 0, negative, right? So this one become negative infinity, Okay, this one have two cases, right? So, and then you say, if I ask you read the limit f of x when x approaches to 0 positive, that means from the right hand side, this one, you keep leading up here, right? So this equal to plus infinity. So you see this case is not, doesn't equal, right? It's not equal. So then this one, you can answer this function doesn't exist, right? At the final, for one you learn up to this level, you will answer also this function, two things, doesn't exist. Second is discontinuous. Okay, for this graph, if I ask you this one, okay, when x approaches 0, so then you do the same way, that's the previous one. But you can answer at the same time, is this is continuous or discontinuous function. In this case, you'll answer discontinuous, right? Discontinuous if the x approach to 0 here, this one. Okay, but if ask you here at this one, yes, this one continuous and exists also the limit. The limit is what? Whatever you lead up to this point, this is the answer. Everyone get the idea now? Okay, so then you see the below graph. If I ask you f of x when x equal to c at this point, yes, because this one exists, right? And you can see the graph informally when you just leave from the graph. When you draw from the left here, right? You can pass to this point, go up, continuous. Okay, so this is a this function is a continuous function. But if I ask you this point, for example, this point is I name is a, right? So then in this one is, this function is discontinuous at x equal to a. Or you can say the limit, when limit of this function, when x approaches a, it doesn't exist. Okay, because one value this equal to this, another value equal to this one. It's different point, you see that? So I think everyone must understand now, okay, because you do a lot of questions already from previous lessons. So now I'll continue one more step. It's a continue, the function or the limit, continuous or discontinuous. That's all. Okay, now we see next more example. This graph is a continuous or discontinuous function. See the first one here, graph number 1 here. Okay, so if I ask you this one at this x equal to c, the function f of x when x at x equal to c is continuous or discontinuous. You see this one become open dot. You see that this one become open dot, right? So this is the open dot. So then this one, of course, is discontinuous. Or you can answer the function no solution or doesn't exist because it's open. Why? You can next you can get the idea from the continuity. So you can see if you plot this graph closer to here, when you up mid this point, you have to lift your pen or pencil, right? Just can jump it up and come to this side, and then you just can continue draw the graph. So in this case, it's discontinuous when x equal to c. So this one discontinuous. Okay, because you have to lace your pen. See that? Because this have one hole here or empty dot. Like you have a bridge. When you walk across the bridge and suddenly they have broken bridge here. How you go on? You have to jump, or if not to why, right? You can jump or have to find something connect. You just can walk through, right? That's the same idea. So in this case, if you find that open dot between the line, this one, the function is doesn't exist before we learn, right? Or no solution, remember? So you answer for no solution or doesn't exist. At the same time, okay, in this case, so at the same time, this one you answer for continue one more. Answer is what? This function is discontinuous. But if I ask you the limit for this case, limit f of x, when x approach to c, right? C, that means this point, right? So then what the answer? The answer is you have to leave for both sides, right? If from limit, say limit f of x from the left, from the right side, like right hand, okay? So x equal to c plus. So you can see you lead from here, right, from the right hand side. So you met this point, and then you lead come here. For example, this point, the answer maybe say 2, okay, assume 2. So it lead equal to 2. And then you lead the limit from the left hand side, okay? So x equal to c negative. Don't forget negative here. So then left hand side, you lead up to here. Then they met to this point, right? Even open dot, but it's equal to what? Same thing, or equal to 2. So in this case, limit, this one equal, correct? This one from the left and from the right, they are equal, correct? So this one equal. So then this limit, when limit f of x when x equal to c, I mean this point exists, the limit exists, okay? But the f of x when x equal to c, no solution, because the open dot for function, remember we learned from the previous. This one no solution, no answer, because this is the open dot. Once you make this case, right? You final answer, you're gonna answer this one is this continuous, this function, this continuous. Okay, why? Because f of x for the first case, number 1 and number 2 here, from this one final for these two cases are not equal. That means the case one, the number 1 not equal to 2. Okay, this one doesn't equal. So then you answer final is say discontinuous. Of course, limit exists, but the function doesn't exist. But then final one, limit f of x not equal to limit f of x. So the final you conclusion discontinuous. Okay, and it's you think about only the normal way. If you see from the graph, right? In informal way, when you see from the graph, if they're open, of course, this one discontinuous, because you have to lift your pen or pencil to the other side. Okay, okay, go next one. This one, if this case, right, if this one discontinuous or continuous at x equal to the c, x equal to c here. Of course, this one discontinuous, because you have to lift your pen, right? When you approach, you closer to this point, you want to come to this line or this function, you have to lift your pen or pencil, right? Just have to jump to this point. So then this one discontinuous when f of x, when just say when x equal to c. Everyone get? Okay, so then discontinuous. And if the how about think about limit? If I ask you limit of this function, when x approach to c, what this limit exists or doesn't exist? This one doesn't exist, right? Does not exist, correct? If we ask about the limit, why? You lead from the left, right? You get value of y, mean this one, correct? For example, this one is maybe 1, okay? But then you lead from the right hand, right? Y is what? For example, this one maybe say 2, 3, maybe 2, 3, maybe 4, for example. So you see from the left equal to 1, from the right equal to 4, then they are not equal, then the limit of this one does not exist. And at the same time, the function f of x equal to what? Cannot, because f of x from this point, you have this one exists, okay, equal to 1. But when you lead at this point, f of x when x equals c, they have two conditions because they have two graph at the same point. But this one is what? Doesn't exist. So final this discontinuous. And at the same time, you see the graph is really clear, because when you plot up to this point, when you go to this function, this right hand side picture, you have to lift your pen, right? Jump from this point to this point. So this one discontinuous. Okay, one see how to see the graph. Now you see this one. See this one. If this one is what? Open dot, of course, very clear. This one, this function is what? Discontinuous, right? Because open dot, you have to lift your pen from left hand side to the right hand side. Or understand, if you move from the right to the left, the same thing. You have to lift your pen or pencil, jump to this side, or this side, jump to this side, because this is an open dot. It's a one broken line here. So it's a discontinuous. But if as limit, of course, they exist, because this one will have the same point. For example, here is equal to 1. Everyone get the idea now? If limit, okay, but f of x, the function, is no solution. Final limit exists, but the function doesn't exist and no solution. Final, they are not equal. So then this one conclusion discontinuous. See this graph, this is a C, okay, this point C. Same thing, you see this one from the left, okay. If you lead from the function f of c, x equal to c here, this is a x. This one you can answer doesn't exist, because when you from the left, you plot approach to this one asymptote, but never touch, okay. But if you want from the right hand side, you really, these 2 points never made. If from the left you jump to the right graph, you have to do something, right? Jump or have to do something. So this one is discontinuous for the function. And limit, what is that about? In this limit, exists or not? If you leave for the limit for this case, from the left approach to plus infinity, right? And from the right approach to plus infinity also. So this one exists, but cannot say what the C is, but you answer as a plus infinity. Okay. So, but if asked about the function, it doesn't exist. And final, this graph, we answer discontinuous. Okay. Okay, now, so now we see more example, next one. More example here. You see, I give you this graph, okay? If at f of x, just say this point, f of x, when x equal to a, right? You see this point a, then function, this is exist or not the exist, or have solution or not. So you see from A here, you lead up, they make this point is an open dot. So in this case, of course, you answer and it's not divided or undivided or no solution, because it's an open dot, right? But if again, see, we repeat again, if I ask you the limit f of x when x approach to A, so what the answer? Yes, x is correct, everyone, because this to the left and to the right you made at this point, they are the same answer. So assume this one is maybe give, but maybe this one they give this as a number, maybe this is a 2 and this is a 4. Maybe I give this one is a point A, maybe, because they did not use a number. Okay, for example, I get this one, give and what name? A, B, C, maybe this point is a D, this point is a D, okay? So then this limit equal to D, correct? Limit of this function f of x when x approach to A, when x approaches A here. So from the left to the right, they made this one, so this is a D, right? So answer D. But if I ask you function when x equal to method A here, so this one is what? No solution, or can answer this one is undivided. Okay, so this can answer this way. But if I continue as this one, this function or limit when x approach to A for limit and x equal to A, in this case, discontinuous or continuous. In this case, we answer as discontinuous. Okay, because of what? The first case one function here, this one no solution, or just say is undivided. but this one equal to D have limit. This is a second case. Then you can say 1 equal to 2. Not equal, sorry, because this is no solution, but this have answer equal to D. So then this one final discontinuous because 1 not equal to 2. Everyone get? So now you see next, if f of x now at the x equal to b, okay? So I change some another color here. If f of x when x equal to b, see that this b, right? So then you see at this b have two graph, right? From the left, this graph, this one on the left, and from the right hand side, you have this graph, correct? So then if you lead for the of this function, right? You have two cases. One, this one doesn't no answer, but if you lead function when b x equal to b here, you answer this one equal to d, correct? Okay, but if you lead the limit, of course, doesn't exist because 1 equal to d, 1 equal to this one. Maybe I keep this one, say this point, right? Maybe a b c d, this one f, maybe. Okay, so if as the limit when f of x when h approach to b here, you see that b here, the key is right here. This is b right here. Okay, so 1 is equal to d from the left hand side, and from the right hand side limit equal to f. So the from the left and to the right is not are not equal, right? So then the limit of this function doesn't exist. Okay, and the function is doesn't equal, it is not equal either. So then at this point, when limit f of x when x equal to b, or even the function x equal to b, final this one answer is what? Discontinuous. Okay, if I ask you continuous or discontinuous, of course, because from this point you have to jump to this point, right? So it's a discontinuous. Everyone get it? So now come to if SC, if f of x, okay, if f of x, now the green one, okay, f of x when x equal to what? To c, right? So at this point, so then you see this one is the only one dot, only dot here, right? So in at this point, because SC have two graph, one's a one dot, one is a this function. Above here is a one function and have one dot here, back dot. So if at this point, if f of x when x equal to c, they have answer because it's a back dot. So you lead from to the y. Okay, for example, you lead up back to the y. Okay, for example, with this one, like I name as a e. Okay, this is a point e. So then when f of x at this point, this graph is only dot, will equal to e, correct? Okay, but if you lead up this point at this point here, for when c f at this point, the function alone, this one no solution. Everyone get? So this one can be answer dot and the graph and the open dot, so different, okay? But at this one, if again, if I ask you, if the limit f of x when x approach to c, limit, now I ask you limit, okay? Don't forget, now I ask you limit. So what the answer? This one limit, no answer because only dot, so no solution. But when you leave this on the top here is a graph, yes, they do have limit because from the left, from the right, they made at this one, even the open dot for limit, they have answer. What the answer? You lead back to the value of y here. For example, I give this point is the number maybe say g, right? So this limit will equal to g, right? Can be any number. Okay, because from the left, from the right, they made at the same point. But the limit at this point, back only one dot, no solution. Limit is a dynamic. They have to be one graph, keep moving, but only if dot, you answer no solution or no, doesn't exist. Okay. Everyone get this is similar to what we learned previous lessons many times already. Now only increase is the answer more is is continuous or discontinuous. That's it. Okay, now we can we can conclude, give the conclusion when it's a continuous or discontinuous. Okay, they have two ways. First one is what? First one, you have it is the graphs, right? You just leave from the graph. If they open dot or open dot like this, so this graph is what? Discontinuous. I mean this function along this graph. Okay, and then if they have like a one point like this, the below, okay, and then you have to jump up to this point. Then this function, when function f of x when x equal to b, in this case, discontinuous, because you have to lift your pen or pencil to the other point, to the other side. Same as this one, you have to lift your pen or pencil from the left hand to the right or right to the left. So this one say discontinuous. Okay, from the graph you consider by that way. And right now we talk about discontinuous or continuous, okay, functions. Now another word, if we do by calculation, show the verb, come up to here, you have 3 steps. Okay, the 3 steps actually we already talked there before here, like in this case, right? So in this first one is what? If you test with f of c is defined, okay? And the second, if you find the limit f of x exists, and if this one, just say this one, if 1 equal to 2, that means this one, number 3, that means the conclusion limit f of x when x equal to c equal to function f of x when x equal to c, then this one is called continuous. Okay, so at x equal to c. So we will work this question example later, next class, next lesson. Okay, I think I leave this one first. Okay, see you next one. Bye bye.